Okay, guys, good evening. Please confirm whether you guys can get me loud and clear, then we can start. Okay. Um, thank, thank you. So I want us to start. I want us to start. So yesterday we were discussing more on subnetting. And the subnetting that we're discussing was about fixed subnetting, and we managed to, do one example together. So I want to believe you guys also, you took your time and maybe did some more examples or other exercises, or like actually review what we covered yesterday. So ideally, we just need to, to practice on all this. Huh? We just need to practice on all this. So that's the most important thing. So today, today I want us to look at the other type of subnetting. Huh? Yes, we actually, discussed yesterday. That is the VLSM. Huh? And now I want us to, you know, uh, to have one example together. You see actually what we can do in regards to VLSM, in regards to VLSM. So that's basically I want us to discuss here. So give us a minute. I need to check what I have. Now, with VLSM, as we said yesterday, it is the most, it is the most used, type of subnetting today. The most used type of subnetting today. In the field, that's actually what people do use. Now, allow me to, okay, let me see. Now I'm sharing my screen. I don't know why it's taking longer. Is it up? Is my screen up or not yet? Okay. Okay. I don't know why it's taking time. It's okay. I don't know whether it's up already or not yet. Okay, thank you. So with the VLSM, that is variable length subnet masking. Now, as the name suggests here, the length, or rather the mask for each subnet will not be the same. Will not be the same. Okay, unlike what we covered yesterday. Yesterday, we actually, see that those masks were the same, all of them. They had the same, mask. But today, what actually we'll be doing will be slightly different from what we did yesterday. So with subnet masking, so I want us to give an example of, let's talk of ICTA, ICT authority. Let's talk of Nairobi branch. Okay. Just an example, so that at least can be a bit practical, assuming Nairobi branch. Okay. Assuming that Nairobi branch, we want to assign 60 computers, the ICTA Nairobi. Let's talk of ICTA Nakuru. Okay. We want maybe to give 30 hosts. 30 hosts. Let's talk of ICTA Msa, that is Mombasa. Let's give this one 13. And let's talk of ICTA. Okay, I'm just giving examples. Turkana, we want to give only 2 hosts. Okay, only 2 hosts are there. So now we are assuming you have been given these subnets. Okay, tell you what the ISP has given you, given subnet. Let's talk of 172.16.10.0 prefix 2024. So actually this is what you have been given by the ISP. So with the ISP, they have no control as long as they have provided you with your subnet. That is it. So it is you now to decide. Now, so assuming your supervisor, your manager, has requested you to assign these computers as follow. Okay, Nairobi, let assign 60. Nakuru, let have 30. Mombasa, let have 13. And Turkana, you can give them 2. Now, as the ICT team or the IT team, now we need to, come up with what? With the subnets for each branch. Subnet for each branch. Now, now something that I want to take note of is CI, we call it CIDR, classless interdomain routing. Classless interdomain routing. Basically, with the CIDR, classless interdomain routing, you just need to understand now each subnet and the number of, each prefix and the number of hosts that each can accommodate. So if we talk of class C, for example, that's what I want us to have. We talk of prefix 24. Okay. With prefix 24, we know that the number of hosts that the entire, the entire block can support is 254. So remember we talked about 255.255.255.0. That is 0. The last octet, the interest octet, has got 8 bits. And to get the number of IP addresses, so it's going to be 2 raised to 8 minus 2. 2 raised to 8 minus 2. So 2 raised to 8 is 256 minus 2, so we get 254 as the hosts that can be accommodated, as the number of hosts that can be. So here, we basically talking about the hosts or the computers that can actually be accommodated here, okay? When you move to the next prefix, 25, so 25, that's a bit borrowed. You remember what we talked about yesterday? That's a bit borrowed, okay? Of course, it's just a matter of subtracting 25 minus 24 is 1. So you know how you're supposed to write that 1 in binary. So it is 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. 7 zeros. Okay? So these 7 zeros, this 0 is what now is helping us to get the number of hosts. Okay? There. Because we are looking at the last octet. So it is 2 raised to 7 minus 2. 2 raised to 7 minus 2. So what is 2 raised to 7 minus 2? What is 2 raised to 7 minus 2? What do we get? 2 raised to 7 minus 2? Am I audible, guys? Okay. Yes, Sharon, 126, correct. 126. 126. Okay. 126. Then I move to prefix 26. So those are 2 bits borrowed. This is what actually we were using yesterday. So 2 bits borrowed means 1, 1, and 6 zeros. Huh? So 2 raised to power 6 minus 2. 2 raised to power 6. What did we get yesterday? Yeah, 62. Yeah, 62. 62 host. Okay, then 27. 27 is 30, correct. Okay, 30, because those are 3 bits borrowed. 27 minus 24, 3 bits borrowed. So remaining are 5. So it's 2 raised to 5 minus 2. So 2 raised to 5 is, is 32 minus 2 is 30. That's what you are getting there. Then prefix 28. How many bits? Yeah, 14 bits, correct. Because there are 4. 2 raised to 4 minus 2. 2 raised to 4, 16. 16 minus 2, 14. So you're getting 14 there. 29. 6, correct. 6. 6. Okay. Then 30. 30. 30. 2, correct. 2. So basically, this more of a format is a CIDR that actually you're supposed to have it in place. Huh? So now with this one in place, now you are good to go. You're good to go. Starting now assigning each of the ICTA branches that we have mentioned up here, the number of the subnets that we're supposed to have. So don't forget, guys, don't forget, you have been given the starting point, and your starting point is this. Your starting point is this. Okay, your starting point is that. So basically what you need to do, allow that starting point. Allow that starting point. Okay. Now, but I'll not put that prefix 24. So according to my CIDR down here, I will check. Okay. Which prefix will give me the number of hosts? which prefix will give me the number of hosts, okay, with the least wastage. Of course, I know 24 can give me, I can get my 60 out of 254. I know 25 can give me, I can get it from 126. 26 years can give me, okay, but the remaining 27 downwards cannot. So the one that you can go for correct is 26. 26. So in that case, just need to have 26 here. Okay. So in terms of in terms of what as subnets and the block size, because that's the most important thing, the block size. The block size, huh? So remember yesterday we worked out the block size. So the block size in that case will be, you see what here? 2 bits borrowed here. 2 bits borrowed, 26, huh? That's all you know about 26. 2 bits borrowed, remaining 6. So convert or change that one to decimal. Change that to decimal, 1, 1, and 6 zeros to decimal. What do you get if you do your conversion? Yes. What do you get? Into decimal? Maybe what I need to do, I can do those binaries, huh? 1, 2, 3, 4, 5, 6, 7, 8, because there's nothing borrowed here. It is 1, 1, then 1, 2, 3, 4, 5, 6, 7. Then here, it is 2 bits borrowed. Then 1, 2, 3, 4, 5, 6. Okay. Then here 3 bits borrowed. So it is 1, 2, 3. Then 1, 2, 3, 4, 5. Okay. Then here, so this is 4 bits. Okay. It's 4 bit, 1, 2, 3, 4. Then 1, 2, 3, 4. Okay. Then okay. So here we have 5, 5. 1, 2, 3, 4, 5. Then 1, 2, 3. Okay, I'm trying to simplify it for you in case you're wondering how to get those number of bits. Then here we have 6. 1, 2, 3, 4, 5, 6. Then 1, 2. Okay. So this is how you need to express these prefixes in terms of bits. Huh? So we just need now to, we just need to, guys, convert them. Of course, to decimal. This will be 0. This will be 128. Okay. If you convert that one, this will be 128. This will be 192, as you have said. Okay. This will be, okay. This will be 224. Now, maybe some people are wondering, how do you get all this? Huh? Now, remember, when changing binary to decimal, we raise a number with the power of 2. 2 raised to 0, 2 raised to 1, 2 raised to 2, up to 2 raised to 7. Huh? So when you do that one, 2 raised to 0, up to 2 raised to 7, so you'll get 2 raised to 7 is 128, okay, followed by 2 raised to 6 is 64, followed by 2 raised to 5, 32, followed by 2 raised to 4, 16, okay, 8 is just half of the other one, 4, half, 2, then 1. So when converting to decimal, your interest is 1. So For example, if you start with this one here, so this is 128. Okay, you get this one here. If you move to the next one, it is 128 plus 64. You get 192. Okay. If you move to the next one, 128 plus 64 plus 32, you get 224. Okay. If you move to the next one, it is 128 plus 64 plus 32 plus 16. You get to 40. Get to 40. If you move to the other one, guys, it is 128 plus 64 plus 32 plus 16 plus 8 to 48. To 48. If you move to the last one now, it is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2. Is it plus? So you get to 52. 52 plus 4. 52. Okay. So that's basically what you need to understand. So that's how you get the decimal equivalent of these binaries. Decimal equivalent of this binary. So when I'm asking you, what will be the what? What will be the block size? It's very simple. Okay. So the block size, you just need to check which prefix do you have. It is prefix 192. So for you to get the block size, it is the magic number 256 minus 192. Okay. What do you get? 256 minus 192. What do you get? What do you get, guys? Correct. 64. 64. So 64 plus 0. 64 plus 0. You get 64. But now, remember Nakuru needs Nakuru needs 30. 30. So 30. So which prefix support 30 here? Which prefix support 30? 27. So you have 27. 27 here. Okay, we have 27 there. Okay, so the block size, this prefix helps you determine the next. This prefix helps you determine the next. Okay, the next subnet. The next subnet. So this is 20. So this actually is 27. So 27 will help you to get the next subnet. So what is 27? So what do you know about prefix 27? So it's very simple. 27 here, it has 3 bits borrowed. 3 bits borrowed. In form of decimal, it is 224. What's the block size? Because that's what we are looking at, the block size. Block size is 224. So 224 you subtract from 256. What do you get? What do you get? Yeah, you get 30. You get 32. 32 plus 64. 32, sorry, 32 plus 64. 96. So you write 96 here. You write 96 here. So which prefix support 13 hosts as per your CIDR? Which prefix support 13 hosts? 28. So you write 20. You write 28 here. You write 28. You write 28. Okay. Finally, finally, you are the last prefix, the last branch, Turkana branch. Okay. So we know prefix 28. So the next subnet, prefix 28. So what is our block size? So what is 28 here? 28, 4 bits borrowed. Remaining should be 1, 2, 3, 4. Okay, remaining should be 4. So total to 40. If you convert that to decimal to 40, so 256 minus 240. So we subtract 240 from 256. You get what? You get what? 16, correct, 16. So 16 plus 96, 16 plus 96, 16 plus 96, 112, correct, 112. Okay, so Antirukana needs 2 hosts. Which prefix supports 2 hosts? 30, 30, okay? So that's how actually you need to work with VLSM, there, variable length subnet masking. Now, so this one, you just need to distribute to each branches the subnet that they're supposed to have on their devices. Okay, I repeat the last one. Okay, the last one, this one, Turkana. You see, you are told to give Turkana 2 computers, and that's what you have done. And again, Turkana is supposed to be on their own subnet. So in that case, so right from here, remember this prefix, the first prefix determines the next subnet. This prefix determines this one, and this one, 28, determine this. So we all know the borrowed bits for this 28 here, 28, which is 240. Okay, so it is 4 bits borrowed, remaining 4. So 240. So 240 subtract 256 to get 16. Huh? So 16 is what now we need to add on top of 96, which gives you 112. 112. Okay, after adding 112, then you come down and check. Huh? So it has 2 hosts. So which prefix supports 2 hosts? So the prefix that supports 2 hosts, as you have seen, is 30. And that's what you write here. So basically, that's how simple VLSM is. Very simple, very straightforward. Okay. So that's actually what you need to know. So I was just summarizing, subnetting that we started yesterday for IPv4. So I want to believe you guys will be able now to to do more on your side, and especially on your the one that you have given on your portal, guys. So that's actually what I wanted to explain. Now I wanted us to introduce the next module. It's about IPv6, but I'm really straining. I have some slight headache, so I cannot concentrate a lot with this my device. I need to get some painkillers, and relax a bit. Today I had a lot from morning hours. It was back to back. So I wanted us to introduce IPv6, but the way I'm feeling, I'm really straining. So if you allow me, I can relax. Then tomorrow we can meet and introduce. So it's the only topic remaining for CCNA 1 that I want us to cover. Then after that, we'll be able now to proceed. Okay. So remember, we have two more courses. That is CCNA 2 and CCNA 3 that also we need to cover within the specified period are there. So maybe with the time remaining, you can now digest what we have covered. You can be taking your module exams, reviewing all this. In case of any challenge, just let me know. We can have your questions being posted, okay, on the chat. Then I'll be able to handle it. Submitting questions that you might have a challenge, okay? And maybe I'll get more of application kind of questions. Also, I'll post them in the group so that at least you can also do about VLSM as well. I'll try and get more. I think I have them somewhere within my device here. I can't trace where, but if I get, I'll post them in the group so that also you can do further subnetting with VLSM. Okay, then tomorrow if you meet, I'll be able to see what you have done. So that's all. Allow me to relax, guys. See you tomorrow, same time. Okay, thank you.